Hello, thank you all so much for joining us for our second session of the electrification training series. We're going to give just a couple minutes to let some more folks join us, but please feel free to fill out the poll as you enter, just so we can get a good feel of the audience. And yeah, we'll get started in just a few minutes. Yes, thank you so much for adding that. In case you haven't seen the chat, Um, questions can be asked at any time by adding them to the Q&A, and we will address them at the end by speaking to our whole panel. But please feel free to put them in the Q&A throughout the entirety of the presentation. I think we are ready to get started. Thank you all so much for joining us again. If you're just arriving, please feel free to fill out the poll. If you hadn't heard my earlier message, we will be taking questions in the Q&A or the Q&A function throughout the entire presentation, but be addressing them all at the end. But please feel free, so that you don't forget your thoughts, to throw them in throughout the whole time. And again, use the Q&A function, not the chat. So I am going to kick us off. My name is Jacqueline Rogge. I am the program associate at the California Housing Partnership, and welcome to the second session of the Affordable Housing Electrification Training Series. Today we are going to be going over planning and financing for all electric new construction. We have a great lineup of speakers who will outline the major aspects of electrifying developments through a case study from Wakeland Housing, illustrating clean energy program layering, developer lessons learned, accessing technical assistance and discussing how IRA resources and programs like Build can benefit your all-electric new construction programs. And if we could move on to our sponsorship page, please. Thank you so much. So this session is mainly brought to you by the Building Initiative for Low Emission Development Program, or BUILD, as it will be referred to, just to save us some time. So BUILD is designed to provide technical assistance and incentives for new all-electric, low-income residential buildings that reduce greenhouse gas emissions. I'd also like to thank our other program partners, LIWIP, CAMR, and SOMA, all electric and decarbonizations that support multifamily affordable housing across the state of California. And thank you to our sponsors, Energy Efficiency for All and the Wells Fargo Foundation for supporting this training series and the work that we do here at the partnership. We hope that you will be able to join us for the next 2 sessions of our electrification training series. Thank you. Slated for September 19th and September 26th. On the 19th, sign up to learn more about how to plan and finance all electric rehab projects. And we'll be finishing our series with the electrification technology operations and maintenance. And those signups are still available on our website. All right. Yes, now on to the speakers, the exciting part. So we'll be starting with Ian Sharples, who works at the California Housing Partnership as a program manager. Ian will be giving a brief introduction to the BUILD program and Zero by Design, which were key players in the Wakeland housing project. We also have with us today Peter Armstrong from Wakeland Housing. He's the Vice President of Real Estate Development, and he is going to share with us a high-level overview of the project that we're focusing on, or Union Tower, but I'll let him tell you a bit more. We also have Tony Kouot from the California Housing Partnership as well. He is a senior financial consultant, and he will be explaining the financial breakdown of the Union Tower project and how different financial sources were leveraged. And then finishing us off will be Ari Usher from the Association for Energy Affordability, or AEA. She's a manager in projects, and she will be giving an in-depth overview of the technical assistance aspect of the project and focusing on how this project, co-leverage different energy efficiency programs. Anyway, thank you so much. And now I'm excited to pass it over to Ian.
Hi, thank you, Jacqueline. I think we got a really great program here for you all today. I was going over the slides yesterday that everybody sent in. I was like, oh yeah, this is some really good stuff. So I'm particularly excited for today's session. What I want to do right now is do a quick introduction of the BUILD program, which we'll get into with more detail down the line. But as Jacqueline mentioned, the BUILD program is a California Energy Commission program that stands for the Building Initiative for Low Emissions Development program. And what this is it's really intended as a market transformation program. So BUILD is intended to help get advanced all-electric technologies into the homes of low-income Californians, and especially new construction developments. Although extensive rehabs are eligible for this program, it's really geared towards new construction for all electric affordable housing, and making sure that those sort of decarbonization benefits are accessible to a wide variety of Californians. What BUILD provides are two things. The first is financial incentives, and the second is technical assistance. So a real quick overview of what sort of financial incentives are available through the BUILD program. We have a base incentive that is calculated based on greenhouse gas emissions avoided through energy modeling. And the TA team can really help you with that if you're not familiar with doing any sort of energy modeling. There's a building efficiency incentive based on how energy efficient the development is above code. There is an incremental photovoltaic incentive based on how much solar you are installing, again above code. And then there's some really cool kicker incentives that are specific dollar amounts for specific greenhouse gas reduction technologies. And a quick update on the funding for this program. In terms of the financial incentives available, San Diego Gas and Electric and PG&E are just about fully subscribed. You're still welcome to submit applications, but just be aware of that. For the SoCal Gas territory, we have about $9 million remaining. So get those applications in ASAP. And then for Southwest Gas, we have about $900,000 remaining. So still some good incentives across a large part of the state. But most importantly, what Build is able to offer is technical assistance services. And Ari's going to get into this in a lot more detail later. But if you are developing a new affordable housing development in the state of California, I highly encourage you to apply for Build TA. It is free. It costs you nothing. Uh, and you can get up to 300 hours of no cost technical assistance. Um, yeah. So what this is able to provide you is support throughout the entire development phase, including design, construction, installing near zero emissions technologies and information on local building permits. They can also help you with maximizing the build financial incentives based on the specifics of your development. There's also a number of educational resources on all electric building design and technologies. So if you're wondering, um, are there, you know, different incentives or different technologies that are available for you in the state of California? They're able to help you with that. If you're wondering about changing building codes, they're able to help you with that. So it's a really great program. It is here to help you. It is no cost to you if you want to apply for it. And if you're in one of the IOU territories that still has funding available, it's a great funding option as well, as Tony will get into in a little bit. We've got some program links here. If you're wanting to fill out an application or learn more about the program, feel free to check these out. There's also another program I want to mention real quickly, and that is the Zero by Design program, which is a program that the Los Angeles Department of Water and Power is revamping as we speak. So there's no real slides on it at the moment, but it is similar to Build, but it's available for market rate construction as well as mixed use construction. So if you're doing, say, a mixed use development where you need to decarbonize a ground floor retail, but you have some affordable housing above that, it's a really great option for layering with Build. Build works well layering with a number of other programs. It's highly encouraged. So I want to make sure folks are aware of that and be on the lookout for Zero by Design materials and information coming out in the coming months and next year. So with that, I want to pass it over to our next speaker, which is Peter Armstrong from Wakeland Housing. Thank you.
Good morning, everybody. Thanks for joining us. Um, I'm really excited to participate in this training. I think, both as, somebody that's very interested in, remedying climate change and other challenges that we're facing right now. And, I have to also thank both California Housing Partnership and AEA. They're both have been, entities that are very mission aligned with Wakeland and have really supported our work. And I'm really happy to be presenting with them and very thankful for all of their service to the, the affordable housing community in California. So a little bit about Wakeland. Wakeland is an affordable housing developer. We're a nonprofit and we've been in business now for approximately 25 years. We've done a lot of work primarily focused in Southern California. So San Diego, Riverside, San Bernardino, and LA counties. I would say that Wakeland as a corporation, as an entity, we've been an early adopter of both energy efficiency, renewable energy, and sustainable features in our buildings. I would say that from the board to the staff and to myself and the project managers and the whole team that works with me, I think it is our organizational goal to remedy climate change, and really, do all the right things in our developments. I would say that, Wakeland has a number of LEED certified buildings, a number of, Greenpoint rated buildings. And, when electrification became sort of the kind of the new standard, the new reach goal, I think Wakeland has been an adopter of that. So we currently have 6 all-electric projects that have been constructed and are in operation, from garden style apartments to type 3 6-story buildings. And Wakeland has participated in the low-income weatherization program, a rehab project that we made all electric, and we've participated in SOMA and Build as well. And we are currently working with AEA and some other partners to do a EPIC Challenge grant to retrofit one of our existing mixed fuel projects to all electric. That's currently ongoing. And I would say that, Wakeland, like probably a number of you, is kind of a medium-sized affordable housing development company. We're not energy or sustainability experts. We don't really have that expertise on staff. And so, the TA benefits that are provided by Build and some of these other programs are really useful for us. It really helps guide our work because we're not experts. Just a little bit about Union Tower. It's a project in the city of National City in San Diego County, and it's one that Wakeland has been working on for quite some time. I would say that it's now in construction, but we probably had 7 or 8 years of pre-development on the project. And there's been many iterations of the project, and we've kind of finally figured out a program that is financially feasible, but it took some time. It's a project that I was counting the sources in our pro forma, and there's like 11 sources. So we've applied for just about every funding source, and thankfully we've secured most of them to make the project feasible now. It's a total of 94 units. It's actually in 2 buildings. One's a type 3 modified building, and one's a type 5 all wood frame construction building. It's a large family project with a set aside of 24 units under the VHIP or the VASH program. So supportive housing for veterans experiencing homelessness. And an important component is that Wakeland is developing this project with a union affiliated partner, and the project is subject to a project labor agreement. And this is a first phase of a redevelopment of a 1960s, 1970s era HUD financed, really a campus. It's a 22-acre campus. So here's the pretty pictures. This is kind of gives you an idea of the site plan. Obviously, all of the buildings in color and detailed are our existing project, and then the non-specific detailed buildings are the community that surrounds it. And that's the rendering. So I'll go ahead and turn it over to the next presenter now. Thanks for letting me participate.
Hey everyone, Tony Kouot, California Housing Partnership here. Really excited to speak with you all about Union Tower. It's a wonderful project with a great team over at Wakeland. As Peter mentioned, this project took a lot of sources and a lot of hard work to put together, but it really looks like it'd be a fantastic project. So I'm really excited to speak with you all about it. Just continuing on from where Peter left off, we'll go into a little bit of the details of the project. The project is, it started construction back in June and is slated to complete construction in May of 2026. There's a little bit longer of a ramp up for lease up or completely occupying the building because of the population that Peter mentioned. Veteran populations just tend to take a little bit longer to lease up. And then we are expecting a conversion to permanent financing in February of 2027. So a little bit longer there as well. The project team for this development consists of Wakeland, of course, as the sponsor and developer. Hudson Capital is the equity investor in the deal. So they are buying up the tax credits and then putting in an equity contribution in the project and becoming part of the limited partnership. JP Morgan Chase will be providing the construction phase and permit phase financing. And then we have a number of soft lenders, as Peter mentioned. We have the California Department of Housing and Community Development. The City of National City has provided quite a bit of funds. The County of San Diego, and then the California Energy Commission. Just to give you a quick run through of the scope of money we're talking about. So Chase is putting in about $12 million as permanent financing. HCD through their multifamily housing program is about $4.5 million. Through their VHIP funds, it's about $7 million. The infill infrastructure grant is about $5.4 million. The County of San Diego, Peter mentioned, is 24 vouchers and about $3.5 million. The National City is putting in all together around $9.5 million. And then Build has filled a really important gap at the end of about $454,000 at the end to bring us to the finish line. In terms of ownership structure, so typically, as I'm sure all of you know, affordable housing developments are owned by a limited partnership. And so in this case, it's Union Tower 1 LP, with the general partners being Wakeland, or being Union Tower LLC, which Wakeland is a sole member of. And then NCPA Union Tower 1, which, as Peter mentioned, the San Diego County Building Trades is a part of, or the sole member of. Then we have the limited partners. So these are typically our investors. So you'll see that Hudson is listed as the limited partner with 99.98% of the ownership. But there's also a special investor, which is our upper tier investor, and it's upper tier governmental investor in Fannie Mae, and they own 0.01% of the partnership that owns the development as a whole. The Build, when I say that Build came in and filled, like a really important part is that there were gaps, so it came in at a really great time. But Build, when those funds are received by our partnership, it has to be structured in a little bit differently than your typical soft source from HCD, the city or the county. Usually in a limited partnership, if you receive a grant, it has to be recognized as taxable income, which can have a negative impact on an investor's willingness to provide capital for their deal, because they are now being taxed on any grant money or any income coming into the partnership. So when we look at funds like Build that come in as a grant, we structure them as a general partner loan. They will be granted typically to the nonprofit general partner, who then will turn around and lend it back to the partnership. And that's kind of that's a way to get around it being recognized as income. So that's what was done here. The funds will be used during construction. So about 75% of that $454,000 will be paid once foundations are poured, and then the remainder will be paid once certificate of occupancy is achieved. A big part of this is also the grantee drafts up all the loan documents. So Wakeland's legal team in Wakeland drafted up the documents, and then that's a big part of a lot of the paperwork that gets done when you're going through closing as well. Okay, and then I'm ready to turn it over to Aaron.
One second while I'm sharing this. Okay, great. Thank you. So thanks, Tony. Thanks, Peter. Thanks, Ian. Thanks, Jacqueline. Thanks to our previous presenters. My name is Ari Usher. I'm a project manager with Association for Energy Affordability. I work on our new construction programs over here at AEA, primarily build. So we've heard about Union Tower now from the perspective of project planning and financing. And in this next section, I'm going to present on the technical systems in an all-electric building, and cover best design practices for making an energy efficient and well operating building under the new all-electric era that we're in. So I will go over domestic hot water, HVAC, and then energy generation and storage systems, aka solar PV and battery. But first, I'm just going to kind of go over a few key concepts on all electric building design to frame the conversation here. So for the purposes of this presentation, we're going to say all electric is defined as a building with no natural gas hookups to the building. And so yeah, so when we say all electric, we mean that all end uses that may be powered by combustion appliances in a mixed fuel building are powered by electricity. So that includes water heating, space heating, and cooking. And the more recent elevation of heat pump technology for space heating, and in particular for water heating, really allows for an energy efficient all electric building when we compare that to older electric resistance technologies. It's important for keeping greenhouse gas emissions low, and just as important for keeping operating energy costs low, both for the residents and the building owners. So when we're thinking about this, the first thing you want to think about is energy efficiency. Dollar for dollar, energy efficiency is going to be the most affordable way to reduce energy use and costs. So when designing an all-electric building, it's going to be most cost-effective to maximize energy efficiency features, and then design on-site energy generation and storage to kind of fill the gap and get as close as possible to net zero within the project budget. Okay, so from there, we're going to hop into domestic hot water plumbing design. And I'm sorry, for some reason, my notes are not moving with my presentation. So apologies as I'm trying to figure out what's going there. So, all right, the first thing we're going to cover is equipment selection. Union Tower has, and so throughout this, I'm going to kind of be illustrating some of these concepts with our case study from Union Tower. It's got a central heat pump water heating plant. Also, I'll be focusing on central systems, but keep in mind that unitary heat pump water heater designs, meaning one water heater per apartment or unit, are also common and appropriate for many buildings, particularly low-rise garden-style buildings. But in a central system, you've got a plant that is made up of a handful of components. So, those components are typically your heat pumps themselves, which heat up the water, your storage tanks. You usually have a swing tank and a mixing valve. And then for distribution, you've got circulator pumps, balancing valves, and you've got also controls to control everything. So here's the equipment that we have on Union Tower. How does it all fit together, though? So what we like to do at AEA is an exercise that I'm going to call the water molecule journey. We're going to, on the next slide, just imagine ourselves as a single molecule of water and figure out how we're going to move through the water heater plant. So without further ado, What we're seeing here is a piping diagram. Let's go ahead and place ourselves in here. We've got the cold water supply to the plant coming in on the left side of the screen. It goes through that series of pipes that you see there and comes out as hot water supply to the building. And that's not all though, because we also have hot water returned to the plant from the recirculation. So let's go ahead and place the equipment. We've got the heat pumps up here. We've got our primary storage tanks. We've got our swing tank, mixing valve, pump, and finally balancing valves. So now I'm going to go ahead and take our molecule of water. So we come in on the cold water supply. The first thing is the piping branches up, goes over to the heat pumps. And over at the heat pumps, what happens is this water is heated up from supply temperature about, usually 50 or 60 degrees in a single pass, all the way up to 140 degrees, very hot water. Then from the heat pumps, that hot water is delivered to the very top of this first storage tank here. And this is our primary storage. So as the heat pumps are running, it's going to charge hot water through to the bottom of this first storage tank, and then continuing in this piping in series over to the top of the second storage tank. And finally, once hot water is charged at 140 degrees all the way down to the bottom here, there will be a signal sent to turn off the heat pumps. We're all charged up. So then what happens is when someone turns on their fixture in their apartment, we've got demand on the system. And so that water molecule will be drawn up from this storage. It comes through the swing tank and over to the mixing valve. So remember, at 140 degrees, that's too hot to be supplied to the building. So we're also going to mix it with cold water here from the cold water supply down to our supply temperature of 120 degrees. So when there's no demand on the system, there's also a water recirculation pump that'll run to keep the piping primed with hot water. And this is really a way to kind of save water, because if those pipes were all full of cold water, the first person to turn on their shower in the morning would have to wait a long time to get hot water, and that's a lot of water down the drain. So we've got this important circulator pump, which is balanced with balancing valves here. So that's, essentially how a plant works. And I just went into detail here because this is, in electrification, one of the newer kind of technologies that we're working with. It's really starting to become prime time for central heat pump water heating. And as you can see, it can be quite complex to design these systems. But when we're thinking about equipment and speccing the equipment, there's a couple of things to consider in terms of energy efficiency. So the first thing is the heat pump efficiency itself. In California, a central heat pump water heater needs to be certified to the Energy Commission as JA14 compliant. So there is, a limited list of heat pumps that can be installed in California, but there's a lot of great options on that list. One thing to call out is systems using CO2 as a refrigerant have really good efficiency ratings because they can operate very well down to even low ambient temperatures. But there's a lot of good options out there. In terms of the mixing valve, something to consider is an electronic mixing valve. A thermostatic mixing valve needs to be balanced manually on plant startup, and then also may need to be balanced throughout operations. So an electronic mixing valve will be balanced automatically, and that really takes out some of that extra work with the manual balancing. And then in terms of circulation, we do need to run those circulation pumps, which does use energy, but we can make sure that, it's a very efficient, energy efficient recirculation line. The way to do that is with a variable speed circulator pump. This will allow it to ramp up and down to provide only the amount of water that needs to be circulated. And combined with that, we'll use thermal balancing valves, which allow distribution to be balanced through each riser based on a temperature signal rather than a specific flow rate. And overall, this will reduce the circulator pump energy use. So then the final thing I'll just mention in terms of equipment is, I think one thing I've probably shown is, the kind of complexity of these systems. So you could consider a skid system. So skid systems are spec'd per the building, but then they're actually, the whole plant is built in a factory, installed on a skid, and then transported to site like that. So on site, all the plumber has to do is connect the hot and cold water lines. And this can, potentially save some costs and headaches in terms of on-site installation costs. So there's a number of organizations, a number of companies who are offering skid systems, including water drop systems. Cal Boiler has one, and then Steffi's has one as well. Great. So let's take a look at the piping diagram for Union Tower. Okay, so central water heating plants are a bit sensitive to piping connections, so it's important to make sure that the connections are all done always per the manufacturer's installation manual. But there's a couple of key concepts to remember. So reverse return piping is going to balance balance water flow through the heat pumps. And then vertical storage tanks are always recommended. It's going to maximize the effective storage of our tanks, but horizontal storage tanks are okay if necessary. In certain cases, they may be needed for the project, and they work just fine as well. Then we see that the primary storage is got to be piped in series for a single pass heat pump, and that the hot water should be returned to the swing tank rather than to the primary storage, again, to protect the stratification of the storage. All right, so now let's really take a look at Union Tower. Building A, the plant is located on the first floor in a dedicated plumbing equipment room. And what happens in this case in an enclosed space is ventilation becomes really important because heat pumps do exhaust cold air, and without ventilation, then the heat resources in the space can become depleted, and the efficiency of the heat pumps can really become degraded. So what we're seeing here, a great design. Heat pump exhaust is ducted directly to the exterior of this enclosure. And we just have to make sure that the internal heat pump fans are able to handle the static pressure from the ducting. Then what we also see is there is an exhaust fan providing ventilation in this room as well. And we've also got a fully louvered set of doors to provide for makeup air to come into the room. All right, so Union Tower is an awesome example of different space planning considerations because we do have different building types. Union Tower Building B, the plant is actually located up on the 5th floor roof. So a couple of kind of different things to consider here. First of all, ventilation becomes a lot easier with an exterior install location. You've got free air, plenty of ventilation there. But what we do have to consider is, can the roof accommodate the additional weight of not only all the equipment, but also the water that's, going to be stored there? 2,000 gallons of water is quite a bit of weight. So a structural analysis will be needed there. And then, we got to think about these equipment components, and they're not all weather rated. So a weatherproof enclosure is likely going to be needed for a roof install. And then finally, here we do see horizontal instead of vertical storage tanks. And this is really about the sight lines. This is up on the roof. You may be able to see those vertical tanks from down on the ground. That's going to be a no-go. So that's why we do have, the option of horizontal storage tanks there. So I think, we can really see that these plants can be really integrated into building design. super well. And with that, I will go on to a little bit about HVAC design. I think it's likely that a lot of folks on this call may be a little bit more familiar with the technology with heat pumps for space conditioning than for water heating. Some mixed fuel designs may still use gas furnaces for space heating. However, increasingly, especially for multifamily buildings, heat pumps are used for all space conditioning, including space heating and space cooling. Even in a mixed fuel building that still utilizes gas water heaters, we're increasingly seeing heat pumps for space conditioning. So I'm not going to focus so much on how the systems work, but I'm just going to bring up a couple considerations for energy efficiency. All right, so let's take a look at Union Tower. So what we see here is a unitary split ducted heat pump system. So for each apartment, there is an indoor fan coil unit and an outdoor compressor that are connected by a refrigerant line set. And we've got pretty high efficiency ratings here. So we've got a SEER between 17.7 and 20.5. And then we got HSPF, which is the heating efficiency, between 10.6 and 11. And these are, a good amount above the mandatory minimum efficiencies. And that's, really going to be driven by an inverter or a variable speed compressor. So it's always important to consider a inverter-driven compressor, a variable speed compressor, rather than like a traditional staged compressor for your heat pump. And that's really going to be the driver of efficiency in terms of this equipment. So let's talk a little bit about distribution and ventilation. We have HVAC, which is heating, ventilation, and air conditioning. It's not just space conditioning. What we're seeing here on this Union Tower unit plan is we've got ducted distribution, which is providing conditioned supply air to every bedroom and living space with a single fan coil unit. And then we've got our ventilation, including an outside air fan, bringing fresh air in, and an exhaust fan, 2 exhaust fans. This is going to be what we call balanced ventilation, and it's going to provide for excellent indoor air quality. And one consideration for energy efficiency would be an ERV. So an energy recovery ventilator is a single piece of equipment that has the supply and the exhaust fan in one cabinet. And additionally, what it also does is it introduces a heat exchanger into the ventilation system. You're able to pass the 2 air streams over each other, and this is allowing to both temper the incoming outdoor air, and it'll also allow the heat pump to run a little bit less because you're not losing that conditioned air that you've just heated up or cooled down through exhaust. So let's go on to talk a little bit about renewable energy and storage. There's a recent developments in solar interconnection. So I'd just like to provide a little bit of context here. In April 15th of 2023, the California Public Utilities Commission, the CPUC, published a new solar PV interconnection tariff. It's called the net billing tariff, but it's also commonly known as NEM 3. And this affects customers served by the electric IOUs. And the big takeaway, NEM 3 as compared to NEM 2, which was the old interconnection tariff, is that the export credit for solar PV generation you send back to the grid has been significantly reduced. Whereas NEM 2, the export credit was pretty close to the retail rate for electricity. NEM 3 is a lot closer to the wholesale rate. So what is happening here is NEM 3 makes self-utilization and battery storage kind of more important for building design, and it really kind of incentivizes these kind of considerations, you want to make sure that you're using as much of the energy that you're producing in the building rather than sending it out to the grid, just because of that reduction in that export credit. Now, I'd like to talk a little bit about battery. It has been codified into energy code. However, it's still not common on most projects. It's, kind of emerging, in the industry currently. So I like to think of it as battery ready. Even if battery can't be installed, when the building is first built, we can consider some things to make the building battery ready for the future installation of battery. We used to have solar ready. I'm sure that a lot of folks on this call might have heard of solar ready. So, solar is often installed on most buildings now, but there was a time when that wasn't the case. So we did, build our buildings with roof area ready for solar. We had conduit, we had space on the electrical panel, and that's what we want to do now for battery as well. We want to make our buildings battery ready. So the important things to consider are going to be planning and isolating for critical loads. If you do want to use battery in the future as a backup in case of an outage, you'll want to kind of plan for what are those critical loads that you want to be able to power during a power outage. And those are typically going to be, lighting, refrigeration, and maybe one outlet in each unit. That'll allow folks to keep medications cool, maybe do a little bit of cooking, and things like that. So planning for your critical loads and then isolating them on your panel. And then, we want to look for the location of future battery, providing for required setbacks, ventilation, and fireproofing and weatherproofing considerations. What I have been learning as we're kind of talking with different developers about their experience with battery is a lot of the fireproofing requirements are still pretty jurisdiction specific for batteries. So, it's really something that may take a little bit of work to assess and figure out, but this is a really good opportunity to kind of build technical assistance where you can, help you to navigate these requirements. So then the other thing that you want to do is provide conduit to your solar PV and your electrical room from that location you've identified for the battery. And then also provide your sub panel in the electrical room for your battery. Yeah, and then, down the line, you can just plug and play your battery into your building. So yeah, that concludes my content. Thanks very much. Just a kind of quick reiteration of the build program. Technical assistance is available in all of the natural gas IOU territories, open and freely available technical assistance, even if the incentive pipeline is filled up. So, and it's also open to, all stakeholders of affordable multifamily all electric construction. And we would be super excited to work with you. Thanks, everyone.
Thank you so much to all of our panelists for going over the project. It was incredibly insightful. We are now going to take questions from the Q&A portion. So if you've thought of any more, please feel free to throw them in, but we'll get started with the ones that are there. So how much of the heating equipment meets the Buy America Build requirements? I think, Ari, this could be for you.
Yeah, I was going to just say, I'm not sure that I'm familiar with that Buy America Build requirements. I don't know, Peter, do you have any insight there?
I don't know the answer to the question. The Buy America, Build America requirements are some new federal requirements that are coming out for affordable housing funding sources. So I think we'll all be very focused on this, over the next few years.
Yeah, I would say in general, Build does not require the Buy America, Build America requirements because it's a state level program. Those are federal level requirements. However, if you're trying to say leverage build with maybe some of the IRA incentives from the Inflation Reduction Act, Greenhouse Gas Reduction Fund, you should be aware of the Buy America, Build America requirements because those are generally tied into those funding sources coming from the federal government. I'm not sure about maybe some HUD programs if they also have those requirements, but I would say in general, if you're dealing with any sort of federal financing, definitely look into that and whether it is required because it tends to be more required for those federal sources.
And then Ian, I think this one could also be for you. Does the build program require developers to use prevailing wage or other labor requirements?
Yes, but it's complicated and we've had some internal discussions and it kind of depends on the specifics of the project that you're working on. If you want to have that conversation, feel free to reach out to me. I'll be happy to try to get better answers for you. I can put my email in the chat and in the answer as well.
My
And-
suggestion would be to consult with your attorneys on these types of questions. I mean, I think even on, like some of the past programs, the legislative or policy intent was not to trigger prevailing wages, but if you didn't do things very carefully, you could trigger, state or federal prevailing wages. So I wouldn't put the consultants on this panel on the hook. I would work with your attorney.
Yeah, that's definitely good advice, Peter.
And could you tell us more about how to request the build TA for PG&E customers?
Yeah, for sure. We can put the link to the TA application in the chat here. I'm going to go ahead and do that. So, like I mentioned, TA is still open and available in PG&E territory. So what you'll want to do is fill out this short online application, and then we'll set up an intake call with you to talk about your project.
Yep, and likewise, you can send me an email. I put my email in the chat. I'll be happy to talk with you about build. But yeah, the link is also in the slides that should be getting sent out after this as well.
Did anyone have any more questions they would like to put in the Q&A at this time while you have all of these lovely panelists in one place?
I would say, for developers, I would say, take advantage of the technical assistance. It's really helpful and it can help you understand the program. It can also help you, just the application portal can be challenging sometimes. So the TA can help with that. And, the TA is also great to, help you specify various products, maybe get a second opinion, if your MEP or your design team is specifying various items. Not all MEPs have a lot of experience working with all electric buildings. And so it's sometimes great to get a second opinion on some of this stuff because, as developers, it's hard for us to be in the technical weeds on all of this.
Thank you so much. Oh, we have another question come in. So one of our attendees said we've run into issues doing battery backup with VNAM. How have others made this work? Ari, I don't know if you want to take this one away.
Yeah, sure. No, that's a great question. I think, in terms of the actual engineering of it, it's totally possible. But in terms of interconnection, it's a little bit more of an emerging question. So yeah, unfortunately, I think to make a long story short, we can work with you on it. It shouldn't be impossible, but it still poses some challenges.
It doesn't look like we have any more questions coming in. If there's nothing else, please feel free to reach out to any of the panelists. If you come up with any questions following this event and want some more answers. I want to thank all of you guys for your wonderful insight and thoughts. This has been incredibly informative. I always love learning a little bit more. And Ian, I didn't know if you wanted to take us away with a little bit about the post-webinar survey. Is that going out for this one?
Maybe.
Okay.
Yeah, be on the lookout for the slides and recordings. We should be sending those out later after this webinar, maybe after the series concludes. But yeah, there may be a little survey included with that. We're definitely interested in your feedback. Anything you might want to hear for next year. If you're interested in, electrification topics, any particular issues that you want us to address or maybe help you work through, we definitely want to hear from you. So yeah, I would say thank you all for attending. Be sure to register for our other two sessions. I think the rehab and maintenance discussions are going to be really good, especially maintenance. I think it's a little bit of a neglected topic when it comes to, the long-term savings you can experience with electrification and decarbonization. So yeah, definitely be on the lookout for those, and hope to see you here again in 2 weeks for our third session.
All right. Thank you all so much. Have a wonderful day.
Thanks, everyone.
Take care.